Number 1. The ocean is so deep we've only scratched the surface. Despite covering more than 70% of the Earth's surface, over 80% of the ocean remains unexplored and unmapped. This is largely because of its sheer depth and pressure. The average depth of the ocean is about 12,080 feet, 3,682 meters, but the deepest part, the Challenger Deep in the Mariana Trench, plunges to around 36,070 feet, 10,994 meters. That's deeper than Mount Everest is tall. To explore such depths, engineers must build submersibles that can withstand pressures exceeding 16,000 pounds per square inch, the equivalent of having 50 jumbo jets piled on top of you. Only a handful of manned missions have reached the Challenger Deep, making it one of the least visited and most mysterious parts of our planet. Number 2. The largest living structure on Earth is underwater. The Great Barrier Reef, located off the northeastern coast of Australia, is the largest living structure on the planet. It spans over 1,400 miles, 2,300 kilometers, and is so vast that it can be seen from space. It is composed of over 2,900 individual reefs and 900 islands, all created by billions of tiny coral polyps over thousands of years. Though it thrives in warm, shallow waters, it's incredibly sensitive to changes in temperature, acidity, and pollution. In recent years, parts of it have suffered from coral bleaching, but conservation efforts continue. Number 3. Deep sea creatures are like aliens on Earth. In the pitch-black depths of the ocean, evolution has given rise to creatures so bizarre, they seem otherworldly. Some of the most infamous include the anglerfish, which uses a glowing lure on its head to attract prey in total darkness. The goblin shark, sometimes called a living fossil, with a terrifying, extendable jaw. The vampire squid, which lives in oxygen-minimal zones and uses bioluminescence to escape predators. Many of these animals rely on chemosynthesis instead of photosynthesis, feeding off chemicals that spew from hydrothermal vents. Number 4. The ocean glows in the dark. Bioluminescence is the production and emission of light by living organisms. It's incredibly common in the deep ocean, where sunlight never reaches. Up to 76% of deep-sea creatures are thought to have bioluminescent capabilities. Some use it for communication, others to confuse predators or attract mates. The Atala jellyfish emits a flashing, burglar alarm to draw attention to its attacker, hoping a bigger predator will swoop in and rescue it, indirectly. Number 5. There are entire ecosystems powered by hydrothermal vents. Discovered only in 1977, hydrothermal vents are like underwater geysers that spew superheated, mineral-rich water from beneath the Earth's crust. Despite the boiling heat and complete lack of sunlight, entire ecosystems thrive around them. Instead of using sunlight, organisms near these vents use chemosynthesis, drawing energy from chemicals like hydrogen sulfide. These ecosystems include giant tube worms that can grow over 8 feet, 2.4 meters, long, blind shrimp, and vent crabs, all entirely dependent on these vents for survival. Number 6. The pressure in the deep sea could crush you instantly. At the deepest parts of the ocean, pressure can reach more than 1,100 times the atmospheric pressure at sea level. That's about 8 tons per square inch, equivalent to the weight of a Hummer H2 SUV pressing on every inch of your body. To survive this, deep-sea creatures have evolved without any air cavities like lungs or swim bladders. That would collapse under pressure. Instead, they're often gelatinous, boneless, and highly adapted to the crushing depths. Number 7. Underwater rivers and lakes exist in the ocean. Strangely enough, there are rivers and lakes within the ocean itself. These are formed when water saturated with brine, super salty water, sinks due to its higher density and collects in seabed depressions, creating a distinct pool underwater. One famous example is the Jacuzzi of Despair, an underwater lake in the Gulf of Mexico. The brine is so salty and toxic with methane and hydrogen sulfide that anything entering it, like fish or crabs, dies quickly. The edge of the brine pool is often lined with dead animals. Number 8. There's an internet of whales communicating across oceans. Blue whales, the largest animals to ever live, can communicate across thousands of miles using low-frequency vocalizations that travel through deep-water channels known as SOFAR, sound-fixing and ranging channels. These channels act as natural amplifiers, allowing whale songs to be heard over vast distances. It's possible that before modern ship noise polluted the oceans, a whale off the coast of South America could have spoken to another near Africa. Number 9. The deep ocean is colder than you think. Temperatures in the deep sea can hover around 2 to 4 degrees Celsius, 36 to 39 degrees Fahrenheit, just above freezing. Even near hydrothermal vents, where temperatures can reach 400 degrees Celsius, 752 degrees Fahrenheit, surrounding water rapidly cools due to the immense pressure. Deep-sea animals have adapted by evolving slow metabolisms, specialized enzymes, and unique biochemical structures that function in the cold and under pressure. Some, like the Yeti crab, even cultivate bacteria on their claws to generate heat and food. Number 10. The ocean contains mountains taller than Everest. Beneath the waves lie massive underwater mountain ranges. The mid-ocean ridge is the longest mountain range on Earth, stretching over 40,000 miles, 64,000 kilometers, across the globe, circling the Earth like seams on a baseball. The underwater mountain Mauna Kea, when measured from its base on the ocean floor to its summit, is taller than Mount Everest, 33,500 feet, 10,210 meters, compared to Everest's 29,032 feet, 8,848 meters. Number 11. The ocean is full of underwater volcanoes. There are an estimated more than 1 million undersea volcanoes, with over 75% of the world's volcanic activity occurring beneath the ocean surface. Some of them are active and can form new islands over time, like Surtsey, which appeared off Iceland's coast in 1963. Volcanic eruptions also release heat and minerals, fueling hydrothermal vent ecosystems and influencing ocean chemistry and circulation patterns. Number 12. Some deep-sea creatures can live for centuries. Certain ocean dwellers defy our understanding of aging. The Greenland shark, for instance, can live up to 500 years, making it the longest living vertebrate known to science. Scientists determined its age by radiocarbon dating proteins in its eye lenses. Another long-lived creature is the ocean quahog clam, one of which was found to be over 500 years old. These creatures grow slowly and live in deep, stable environments with little disturbance. Number 13. The ocean holds zombie worms that eat whales. When a whale dies and sinks to the seafloor, it creates a whale fall, a sudden, massive influx of nutrients to the deep sea. Within days, specialized creatures arrive, including the Erie ostax or zombie worm, which bores into the whale bones using acid and consumes the marrow. Zombie worms have no mouth or stomach. They rely on symbiotic bacteria to digest bone material. These strange worms thrive for years on a single whale fall. Number 14. Sound travels faster and farther underwater. Sound waves travel over 4 times faster in water than in air. Approximately 1,484 meters per second in seawater, compared to 343 meters per second in air. This makes the ocean an excellent medium for sound-based communication. This property has even been exploited by submarines and marine animals. However, it also means that noise pollution from ships, sonar, and oil drilling travels widely, affecting everything from whales to fish larvae. Number 15. The deep ocean is home to gigantism. Many deep-sea animals exhibit deep-sea gigantism, a phenomenon where species grow much larger than their shallow water relatives. Some examples: Giant isopods the size of dinner plates, colossal squids with eyes the size of dinner plates, Japanese spider crabs with leg spans up to 12 feet. The exact cause is debated, but factors may include colder temperatures, slower metabolisms, delayed maturity, and limited predation. Number 16. There's a hidden second ocean beneath the Earth's surface. Scientists have discovered that beneath the Earth's crust lies a massive underground reservoir of water, possibly 3 times the volume of all the oceans combined. It's stored not in liquid form, but within a mineral called ringwoodite, located in the mantle transition zone about 400 to 700 kilometers, 250 to 435 miles beneath our feet. This hidden water may be key to understanding the origin of Earth's surface oceans and could help explain tectonic activity, earthquakes, and even long-term climate regulation. It reshapes our concept of where water exists on Earth, not just in seas, lakes, and glaciers, but deep within the Earth itself. Number 17. There are brine pools that behave like liquid mirrors. Brine pools, sometimes called underwater lakes, are dense, hypersaline pockets of water that form when salt seeps up from ocean sediments. Because they are so salty, these pools sit on the seafloor like independent bodies of water, often with their own waves, shorelines, and surface tension. Divers have reported seeing ripples and reflections on the surface, like peering into a mirror at the bottom of the sea. Life around these pools is highly specialized. Some extremophiles and tube worms thrive at the pool's edges, despite the fact that the pools themselves are toxic to most marine life due to high levels of methane and hydrogen sulfide. Number 18. Coral reefs are the rainforests of the sea, and they're dying. Although they cover less than 1% of the ocean floor, coral reefs support approximately 25% of all marine species, making them one of the most diverse ecosystems on the planet. Coral reefs are made of tiny colonial animals called polyps, which secrete calcium carbonate to build the reef structure over generations. These vibrant ecosystems are under threat from climate change, ocean acidification, pollution, and overfishing. When water temperatures rise, corals expel the algae, zooxanthellae, that live in their tissues and provide energy through photosynthesis. This causes the corals to turn white, a phenomenon called coral bleaching, and if prolonged, can result in mass die-offs. Number 19. Deep-sea fish often have transparent heads and barrel eyes. The barrel-eye fish, Macropina microstoma, is a small deep-sea fish known for its transparent, dome-shaped head through which you can actually see its green, tubular eyes. These eyes point upward to detect prey silhouetted against the faint light above, but can also rotate forward when the fish feeds. Its head is filled with fluid, and the outer casing acts like a natural diving bell to withstand pressure. This adaptation helps it target prey with incredible precision in a habitat where visibility is almost non-existent. Number 20. Marine snow is the constant rain of death that feeds the deep. In the abyssal depths where sunlight never reaches, most life depends on a constant shower of organic debris called marine snow. This includes bits of dead plankton, fecal matter, mucus, scales, and other biological particles slowly sinking from the upper ocean layers. Though the term may sound poetic, this snow is essentially a drifting rain of decay. It can take weeks to months to fall to the seafloor. In areas with little other food, organisms like sea cucumbers, brittle stars, and deep-sea fish survive almost entirely on marine snow. Number 21. The Midnight Zone is a realm of perpetual darkness. The ocean is divided into light-based zones, and one of the most mysterious is the bathypelagic zone, often called the Midnight Zone. It begins at around 1,000 meters, 3,280 feet, and extends to 4,000 meters, 13,123 feet. No sunlight penetrates here, and it's home to some of the most bizarre and well-adapted organisms on Earth. Creatures with no eyes, bioluminescent lures, enormous jaws, or expandable stomachs. The pressure is immense, and temperatures hover just above freezing. Despite the inhospitable conditions, life not only exists but thrives. Number 22. There are fish that walk on the ocean floor. Some fish don't swim, they walk. The handfish, batfish, and sea robin use modified fins to scuttle across the seabed. These fish often live in coral reefs, muddy ocean floors, or deep trenches. The red handfish, found off the coast of Tasmania, is critically endangered and uses its pectoral fins like hands to stroll along the seafloor. Scientists believe this locomotion evolved to allow these creatures to hunt prey hiding in sediment or navigate complex reef structures. Number 23. The ocean contains the world's largest migration. Every night, billions of tiny creatures, including zooplankton, squid, shrimp, and fish, rise from the deep sea to the surface in search of food, only to descend again before dawn. This massive vertical migration, known as diel vertical migration, is considered the largest migration on Earth by biomass. It's as if the entire deep ocean comes to life each night, forming layers of living creatures that can even be detected on sonar. These migrations play a crucial role in carbon cycling and oceanic food chains. Number 24. The ocean has underwater waterfalls. In places where cold, dense water meets warmer water, the heavier water cascades downward, creating underwater waterfalls. The largest is the Denmark Strait Cataract, located between Greenland and Iceland. This submerged waterfall plunges more than 11,500 feet, 3,500 meters, over 3 times the height of Niagara Falls, and transports over 175 million cubic feet of water per second, making it the largest waterfall on Earth by volume and height. Number 25. The ocean has underwater canyons larger than the Grand Canyon. While the Grand Canyon is awe-inspiring, it pales in comparison to some underwater canyons. The Zemchug Canyon, located in the Bering Sea, is the largest submarine canyon in the world. It's deeper and wider than the Grand Canyon, with a depth of over 8,500 feet, 2,600 meters, and a width of more than 62 miles, 100 kilometers. These canyons are carved by powerful currents and landslides, and they often harbor rich biodiversity, acting as hotspots for marine life like whales, deep-sea corals, and migratory fish. Number 26. The ocean's currents are like giant conveyor belts. The ocean is crisscrossed by massive thermohaline circulation systems, often referred to as the global ocean conveyor belt. These currents transport warm, salty water from the tropics to the poles and cold water back to the equator. This movement not only regulates global climate but also distributes nutrients and oxygen across ocean basins. If this conveyor belt slows or stops, something scientists worry could happen due to melting ice caps, it could trigger catastrophic changes in global weather patterns. Number 27. Some jellyfish are functionally immortal. The Turritopsis dohrnii, often called the immortal jellyfish, has the ability to revert its cells back to a juvenile state after reaching adulthood, a process known as transdifferentiation. This means it can theoretically live forever, unless eaten or killed by disease. This incredible survival mechanism makes it a hot topic in regenerative biology and aging research. It might even hold clues to unlocking immortality in other organisms. Number 28. Tsunamis can travel at jetliner speeds. Tsunamis are not just giant waves, they're fast, deep energy phenomena caused by undersea earthquakes, landslides, or volcanic eruptions. In open water, a tsunami may only be a few feet tall but can travel at speeds exceeding 500 miles per hour, 805 kilometers per hour, similar to a commercial jet. When the wave approaches shallow waters near coastlines, it slows down and grows in height, sometimes forming waves over 100 feet, 30 meters tall. These waves can cause catastrophic damage in minutes. Number 29. The scent of the sea comes from plankton farts. That salty, sulfuric smell of the ocean? It's largely due to dimethyl sulfide, DMS, a compound produced when phytoplankton, microscopic marine algae, are consumed by zooplankton and bacteria. DMS plays a crucial role in cloud formation and climate regulation by promoting the condensation of water vapor in the atmosphere. So, ironically, the scent of the sea is a byproduct of microscopic life, and one that affects the global weather system. Number 30. Underwater earthquakes shape the seafloor daily. The Earth's tectonic plates are in constant motion, and many of the world's earthquakes occur beneath the ocean floor. These undersea quakes often result in seafloor spreading, subduction, and the formation of new geological features like ridges and trenches. Some of the most active seismic zones are located along the Ring of Fire, a path that encircles the Pacific Ocean and is home to 75% of the world's volcanoes. Submarine earthquakes can also trigger tsunamis, reshape coastlines, and release methane stored in deep sediments. Number 31. Some creatures use light not to attract prey, but to hide. Bioluminescence in the deep ocean isn't just for luring prey or attracting mates, it's also used for camouflage. Many midwater creatures employ a strategy called counterlumination, in which they produce light from their bellies to match the dim light coming from above. This makes them nearly invisible when viewed from below, helping them evade predators in the twilight zone of the ocean. Species like the hatchetfish, squid, and certain shrimp have evolved specialized light-producing organs called photophores for this very purpose. Number 32. Some oceans are acidifying at alarming rates. Due to increased carbon dioxide in the atmosphere, oceans are absorbing excess CO2, forming carbonic acid in the process. This leads to ocean acidification, which disrupts the ability of marine organisms, especially those with calcium carbonate shells, like corals, clams, and plankton, to build and maintain their skeletons. Since plankton are foundational to the marine food web, even small shifts in their populations could ripple across the entire ecosystem. By 2100, some ocean regions could be more acidic than they've been in millions of years. Number 33. The Mariana Trench hosts unique microbial life that eats rocks. The Mariana Trench isn't just home to giant amphipods and snailfish. It also hosts some of the most ancient and extreme forms of microbial life ever discovered. Scientists have found rock-eating microbes that feed on serpentinized peridotite, a rock formed from Earth's mantle. These microbes survive in total darkness, frigid temperatures, and crushing pressures. Some scientists speculate similar organisms might exist on icy moons like Europa or Enceladus, where oceans lie beneath frozen crusts. Number 34. Rogue waves are real, and they can swallow ships. Once thought to be sailors' myths, rogue waves, also known as freak waves, are now recognized as real and extremely dangerous. These are giant waves that appear suddenly and can reach heights of 50 to 100 feet, 15 to 30 meters, even in relatively calm seas. They form when several smaller wave systems combine at just the right moment, a phenomenon called constructive interference. The first scientific proof came in 1995 when a 25.6 meter, 84-foot, wave struck the Dropner oil platform in the North Sea, confirming what mariners had described for centuries. Number 35. There are mountains of manganese at the bottom of the sea. The deep seafloor is littered with polymetallic nodules, potato-sized rocks rich in valuable metals like manganese, nickel, cobalt, and rare earth elements. These nodules form over millions of years as metals precipitate from seawater onto particles of debris. Found especially in the Clarion-Clipperton zone of the Pacific, these nodules are attracting attention for deep-sea mining. But the environmental risks are enormous. Disturbing these areas could wipe out ecosystems we haven't even discovered yet. Number 36. Deep-sea sponges can live for thousands of years. Sponges may not look impressive, but some species are among the longest living animals on Earth. The glass sponge Anoxyclix jabini, found in the frigid Antarctic depths, may live over 10,000 years, based on its extremely slow growth rate. These sponges form reefs, much like coral, that provide shelter and food to other organisms. Their silica-based skeletons can grow into elaborate latticework structures that look like delicate crystal vases. Number 37. Whales change the chemistry of the ocean. Whales don't just swim in the ocean, they shape its ecology. When whales dive and surface repeatedly, they move nutrients vertically through a process called the whale pump. Their massive defecations also release essential nutrients like nitrogen and iron into the photic zone, stimulating plankton growth. Before industrial whaling, the oceans were far more fertile thanks to these natural cycles. In a very real way, whales acted as ecosystem engineers, fertilizing entire regions of the ocean with their presence. Number 38. Giant squid were a myth until we found them. For centuries, tales of the Kraken haunted sailors' imaginations. These stories turned out to have some basis in fact. The giant squid, Architeuthis dux, is real and can grow up to 43 feet, 13 meters in length. They live at depths of 1,000 to 3,000 feet, making them hard to study. The first video footage of a live giant squid in its natural habitat wasn't captured until 2012. They have the largest eyes in the animal kingdom, each as big as a basketball, to detect faint light and predators like sperm whales, their greatest natural enemies. Number 39. The ocean floor is littered with shipwrecks. There are an estimated 3 million shipwrecks scattered across the ocean floor, from ancient Roman merchant ships to World War II submarines. Many remain undiscovered, acting as time capsules of history. One of the most remarkable is the Endurance, the ship of Antarctic explorer Ernest Shackleton, which sank in 1915. It was found in pristine condition in 2022, preserved by the cold, oxygen-poor waters of the Weddell Sea. Some wrecks even become artificial reefs, housing vibrant marine life. Number 40. There are underwater forests of kelp taller than trees. Kelp forests, especially giant kelp, Macrocystis pyrifera, are among the most productive ecosystems on Earth. These towering algae can grow up to 2 feet, 60 centimeters, per day and reach heights of 100 feet, 30 meters, creating underwater forests teeming with life. Kelp forests provide food and shelter for thousands of species, from sea otters to nudibranch. They also capture carbon, stabilize the seafloor, and protect coastlines from erosion. Like coral reefs, they're under threat from climate change and ocean warming. Number 41. The ocean produces over half the oxygen we breathe. Although we often credit rainforests as Earth's lungs, it's the ocean, especially phytoplankton, that produces more than 50% of the world's oxygen through photosynthesis. These microscopic organisms float near the surface and use sunlight to convert carbon dioxide into oxygen. A single drop of seawater can contain thousands of phytoplankton, forming the base of the marine food web. Yet, changes in temperature, acidity, and pollution are putting phytoplankton at risk, which could have cascading effects on Earth's atmosphere and ecosystems. Number 42. Underwater earthquakes can create pockmarks and mud volcanoes. The seafloor is dotted with pockmarks. Large craters caused by explosions of gas and mud, often the result of geological instability or the buildup of methane hydrates. In some areas, these craters stretch for miles and resemble the surface of the moon. Some even house mud volcanoes, which erupt not lava, but sludgy mixtures of water, gas, and sediments. These volcanoes can be over 1,000 feet tall and are sometimes linked to seismic activity or the movement of tectonic plates. Number 43. The sperm whale can dive deeper than any other mammal. The sperm whale holds the record for the deepest dive by a mammal, over 10,000 feet, 3,000 meters, in search of squid. These dives can last up to 90 minutes. To survive such extremes, sperm whales collapse their lungs, slow their heart rate to just a few beats per minute, and rely on oxygen stored in their blood and muscles. They also emit powerful echolocation clicks, some of the loudest sounds produced by any animal, to navigate and hunt in total darkness. Number 44. Deep-sea corals are older than the pyramids. Unlike tropical corals, cold-water corals grow slowly in deep, dark waters. Some coral colonies off the coast of Norway and New Zealand are over 4,000 years old. These corals build massive reef structures over millennia, providing habitat for deep-sea fish, shrimp, and crabs. Because they grow so slowly, these corals are highly vulnerable to disturbance. Trawling and deep-sea mining can destroy ecosystems that have taken thousands of years to form, sometimes in a single pass. Number 45. The ocean floor is constantly recycled. Thanks to plate tectonics, the seafloor is constantly being renewed and destroyed. New crust forms at mid-ocean ridges, where molten rock emerges and spreads outward. Eventually, this crust is subducted beneath continents at oceanic trenches. This cycle means that the ocean floor is relatively young. While some continental rocks are over 4 billion years old, the oldest oceanic crust is less than 200 million years old, a mere blink in geological time. Number 46. Deep-sea mining is about to begin, but at what cost? Corporations are now eyeing the deep ocean as the next frontier for extracting resources, especially for batteries and electronics. However, mining the Clarion-Clipperton Zone or seamounts could devastate fragile habitats and stir up plumes of sediment that choke filter-feeding organisms. Because we know so little about the deep sea, some areas have more unknown species than known. Many scientists are calling for a moratorium until we better understand what's at risk. Number 47. Underwater caves are among the most dangerous places on Earth. Submerged cave systems, such as those found in the Bahamas, Yucatan Peninsula, and Florida, are vast and treacherous. They can extend for hundreds of miles and reach depths of over 1,000 feet, making navigation extremely difficult. These caves house ancient fossils, unique life forms, and even artifacts from early human civilizations. But they are so dangerous to explore that only elite cave divers attempt them. Many have perished trying to map their complex systems. Number 48. Thermoclines create underwater walls of heat and sound. A thermocline is a distinct layer in the ocean where temperature changes rapidly with depth, usually between the warm upper layers and the colder deep waters. This creates a kind of thermal boundary that can bend light and sound. Submarines exploit thermoclines to hide from sonar detection, as sound waves bend when they hit these thermal layers. Marine animals also adjust their movements depending on thermocline depths to optimize energy and avoid predators. Number 49. Sea cucumbers breathe through their butts. Many species of sea cucumbers breathe by drawing water in through their anus and extracting oxygen with internal respiratory trees. Some even eject part of their internal organs as a defensive mechanism, distracting predators with their sticky, toxic innards. These strange creatures are essential for seafloor ecosystems. They recycle nutrients by digesting sediment, turning waste into fertile ground for microbes and invertebrates. Number 50. The deep sea is one of Earth's final frontiers. With over 80% of the ocean unexplored, the deep sea remains one of the last great unknowns of our planet. We know more about the surface of the Moon and Mars than we do about what lies beneath 200 meters of seawater. With every expedition, whether by ROV, remotely operated vehicle, submersible, or autonomous drone, we discover new species, strange geological formations, and clues to Earth's origin, and even the potential for life beyond our planet. Number 51. The bloop, a mysterious sound that baffled scientists. In 1997, a powerful, ultra-low-frequency sound was detected by underwater microphones thousands of kilometers apart. Nicknamed the bloop, it was louder than a blue whale and seemed to originate from a remote part of the southern Pacific Ocean near Antarctica. For years, conspiracy theories flourished. Was it a giant sea monster? A secret weapon? Aliens? Eventually, NOAA concluded the most likely source was an icequake, massive cracking of an ice shelf. Still, The immense power and mystery of the sound remains iconic in deep-sea lore, reminding us how much we still don't know about underwater acoustics. Number 52. Marine viruses outnumber all other marine life combined. The ocean teems with viruses, so much so that if you lined up all the viruses in the ocean end to end, they would stretch beyond the edge of the known universe. Estimates suggest there are 100 million viruses in the ocean. Most of these viruses don't infect humans. They infect bacteria and plankton, playing a vital role in regulating marine populations and cycling nutrients. In fact, viruses kill about 20% of all marine microbes each day, releasing organic matter that feeds other organisms. They are the unseen force behind ocean ecology. Number 53. Some fish communicate using electricity. The elephant-nosed fish, along with other species of weakly electric fish, use low-voltage electric fields to communicate, navigate, and find prey in dark or murky waters. They generate these signals using specialized cells called electrocytes. In deep or turbid environments where vision is useless, electrical communication allows for courtship, territorial disputes, and schooling behaviors. It's like sonar, but biological. Some species even emit distinct frequency patterns that function like individual names. Number 54. The ocean has its own weather systems. Not only does the ocean influence global weather, but it also has internal weather systems, such as ocean eddies, currents, and internal waves. These can be massive. Some eddies are over 300 miles wide and can last for months or years. Internal waves, for example, can occur between layers of different water densities and rise over 100 meters tall. These waves are invisible from the surface, but can be tracked using satellites. They help mix nutrients and heat, affecting marine life and climate. Number 55. Some deep-sea organisms use antifreeze proteins to survive. In the frigid waters near Antarctica and the deep sea, certain fish, like the Antarctic toothfish, produce specialized proteins that act as biological antifreeze, preventing ice crystals from forming in their blood. These antifreeze glycoproteins bind to small ice crystals and prevent them from growing, allowing fish to survive in sub-zero temperatures that would freeze the blood of other organisms. This adaptation is so unique that it's being studied for medical applications, such as preserving organs for transplant. Number 56. Tsunamis can cross entire oceans without losing energy. Unlike regular surface waves, tsunamis involve the movement of the entire water column, from the seafloor to the surface. This means they can travel across entire oceans with little loss in energy. For example, the 2004 Indian Ocean tsunami, triggered by a massive undersea earthquake, traveled over 3,000 miles and still caused devastating waves in East Africa. Because of their long wavelengths, up to 100 miles, tsunamis can move unnoticed in deep water, only rising in height as they approach shore. Modern tsunami warning systems are based on deep ocean pressure sensors that detect this underwater energy surge. Number 57. Black smokers are underwater chimneys of metal-rich smoke. Located near hydrothermal vents, black smokers are underwater chimneys that belch out dark, mineral-rich fluids at temperatures up to 400 degrees Celsius, 752 degrees Fahrenheit. When this superheated water meets the cold ocean, metals like iron, copper, and zinc precipitate out, forming towering black columns. These smokers are often surrounded by strange ecosystems that depend on chemosynthetic bacteria rather than sunlight. Entire communities, including giant tube worms, clams, and blind shrimp, live in these environments, isolated from the rest of the biosphere. Number 58. Deep-sea creatures don't follow a day/night cycle. In the sunlight zone, marine animals follow circadian rhythms, hunting or hiding based on the sun. But in the deep ocean, where sunlight never penetrates, many creatures have evolved to ignore time altogether. Some species exhibit ultradian rhythms. Others operate purely based on food availability or pressure changes. In hydrothermal vent ecosystems, scientists have even found organisms whose biological clocks are tuned to tidal patterns or chemical shifts, rather than light. Number 59. The sea contains methane ice that burns underwater. Methane clathrate, or methane hydrate, is a form of ice that traps methane gas in crystalline structures under pressure. Found under Arctic permafrost and along continental margins under the ocean, these ices burn when lit, even underwater. Methane hydrates contain more carbon than all fossil fuels combined, making them a potential energy source and a serious climate concern. If ocean temperatures rise, massive methane releases could trigger climate tipping points, possibly contributing to past mass extinctions. Number 60. Ocean trenches are Earth's deepest natural features. Ocean trenches form where one tectonic plate subducts beneath another. The deepest of these is the Mariana Trench, stretching over 1,550 miles, 2,500 kilometers, and plunging nearly 7 miles deep, 11,000 meters. Conditions at these depths are unimaginable. Complete darkness, near freezing temperatures, and pressures over 1,000 times sea level. Life persists here, but it's minimal and incredibly specialized. Creatures like amphipods, snailfish, and microbes thrive in ways that challenge our understanding of biology. Number 61. Seamounts are hotspots of biodiversity. Seamounts are underwater mountains formed by volcanic activity, often rising thousands of feet from the ocean floor. Though submerged, they act like islands, disrupting currents and creating nutrient-rich upwellings. These isolated ecosystems are biodiversity oases, attracting everything from deep-sea corals to schools of tuna and pods of dolphins. Yet, many remain unexplored and unprotected. Bottom trawling can strip these ancient ecosystems in minutes, destroying centuries of growth. Number 62. Bioluminescent sharks exist. Several shark species, like the lantern shark, are capable of bioluminescence. These small, deep-water sharks produce light from photophores on their bellies and fins, potentially for camouflage, communication, or mate attraction. One species, the kitefin shark, can grow over 5 feet long and emits a greenish glow, making it the largest known luminous vertebrate. The light may help it sneak up on prey from below or disguise itself from predators. Number 63. Sound mapping is the new frontier of ocean exploration. Because light cannot penetrate deep water, scientists use multi-beam sonar, LiDAR, and passive acoustic mapping to explore the ocean floor. These tools help us see underwater in high resolution, revealing shipwrecks, coral reefs, fault lines, and undersea volcanoes. Projects like Seabed 2030 aim to map the entire seafloor by 2030. As of now, only about 25% of the ocean floor has been adequately mapped. Each new survey uncovers surprising features: undersea mountains, vast ridges, or ancient landslides. Number 64. The ocean has blue holes, sinkholes in the sea. Blue holes are massive marine sinkholes found in shallow coastal waters, often formed during the last ice age, when sea levels were lower. One of the largest is the Great Blue Hole in Belize, over 1,000 feet, 305 meters, across and 400 feet, 122 meters, deep. These underwater caves often contain layers of anoxic, oxygen-free water where unique microbial life thrives. Some even hold preserved fossils or ancient stalactites, offering a glimpse into Earth's climatic and geological past. Number 65. The ocean has dead zones where life cannot survive. Dead zones are areas of the ocean so low in oxygen that most marine life cannot survive. They occur when excess nutrients, usually from agricultural runoff, fuel algal blooms. When the algae die, their decomposition consumes oxygen, creating hypoxic zones. One of the largest is in the Gulf of Mexico, stretching over 6,000 to 7,000 square miles annually. These zones are growing globally due to pollution and warming seas, causing mass fish die-offs and altering food webs. Number 66. Some jellyfish swim upside down for a reason. The Cassiopeia, or upside-down jellyfish, lies on the seafloor with its bell facing downward and tentacles upward. This exposes its tentacles to sunlight, allowing the symbiotic algae living inside to photosynthesize and provide nutrients. Instead of using their tentacles to sting prey, they mostly absorb energy from their algae partners and pulse gently to increase water flow. They've even been observed releasing mucus filled with stinging cells, like a floating minefield to deter predators. Number 67. The ocean is slowly becoming louder. Thanks to increased shipping traffic, seismic exploration, and naval activity, the ocean is now filled with anthropogenic noise. This is problematic because many marine animals, whales, dolphins, fish, rely on sound for communication, navigation, and mating. Increased noise disrupts migration paths, causes disorientation, and leads to behavioral changes or even strandings. Some whales have begun yelling louder, increasing the intensity of their calls to be heard over the din. Number 68. One of the most colorful fish lives in total darkness. The stoplight loosejaw is a deep-sea dragonfish that uses two types of bioluminescence, green and red. Red light is rare in the deep sea because it's absorbed quickly in water and most animals can't see it. But the stoplight loosejaw can both emit and detect red light, allowing it to spot prey without being seen, a form of stealth vision. It uses a hinged jaw to launch surprise attacks with almost no water resistance, giving it a lethal advantage. Number 69. Sea stars can regrow entire bodies. Sea stars, starfish, possess extraordinary regenerative abilities. Some species can regrow entire bodies from a single arm, as long as part of the central disc remains. This ability stems from a population of totipotent cells, similar to stem cells, which can differentiate into any tissue type. This regeneration takes weeks to months, depending on species and environmental conditions. Scientists are studying sea stars to better understand wound healing and organ regeneration. Number 70. The ocean might be the origin of life itself. Many scientists believe life on Earth began in the ocean, possibly near hydrothermal vents. These mineral-rich, energy-abundant environments offer all the ingredients necessary for life: water, heat, complex molecules, and energy gradients. Experiments have shown that amino acids and organic compounds can form spontaneously in such conditions. If life began in the sea, then everything, from forests to skyscrapers, ultimately traces its origin to the deep, dark abyss. Number 71. The ocean's thermohaline circulation acts like a planetary heartbeat. The ocean's thermohaline circulation, often called the global conveyor belt, is a massive system of deep ocean currents driven by differences in water temperature, thermo, and salinity, haline. This system moves water, nutrients, oxygen, and heat across the globe. A parcel of water sinking in the North Atlantic can take 1,000 years to travel the entire circuit and resurface in the Pacific. Disruptions to this conveyor, such as from melting Greenland ice, could throw global weather systems into chaos, freeze Europe, dry out the Amazon, and even hasten sea level rise along some coastlines. Number 72. There's a gigantic sponge reef off the coast of Canada, once thought extinct. In 1987, scientists off the coast of British Columbia discovered a living glass sponge reef stretching over 1,000 square kilometers, the first seen in over 100 million years. These reefs were thought to have disappeared with the dinosaurs, but here they were, thriving in cold, deep waters. The sponges build delicate silica skeletons that resemble fragile glass lattices. These reefs filter thousands of liters of water each day, providing a habitat for fish and invertebrates. Their fragility, however, makes them vulnerable to damage from fishing trawls and sedimentation. Number 73. The vampire squid is neither vampire nor squid. The vampire squid, Vampiroteuthis infernalis, is a deep-sea cephalopod that exists in the oxygen minimum zone between 600 and 900 meters deep, where little else survives. Its name means vampire squid from hell, but it neither sucks blood nor acts aggressively. Instead, it drifts passively and feeds on marine snow, detritus from above. When threatened, it inverts its arms to reveal fleshy, spiny projections and ejects bioluminescent mucus filled with glowing particles to distract predators. It's a perfect example of a creature adapted for energy efficiency and deception. Number 74. The deep ocean is a chemical factory of unknown compounds. From hydrothermal vents to coral reefs, deep-sea environments produce biologically active compounds unlike anything found on land. Many of these are being researched for antibiotics, anti-cancer drugs, and antiviral therapies. One such compound, salinosporamide A, derived from ocean sediment bacteria, has shown promise in treating multiple myeloma, a form of cancer. Another, ziconotide, derived from cone snail venom, is 1,000 times more potent than morphine and is used to treat chronic pain, without addictive effects. Number 75. Blue whales can be heard across oceans. The blue whale, the largest animal to have ever lived, produces low-frequency sounds that can travel up to 1,000 miles, 1,600 kilometers, underwater. These infrasonic calls, typically between 10 to 40 hertz, are below human hearing but perfect for long-distance communication in the ocean. Blue whales may use these calls to locate mates, coordinate migrations, or navigate across vast distances. Some scientists believe whale songs once spanned entire oceans before noise pollution from ships drowned them out. Number 76. Ocean currents shape the climate of entire continents. The Gulf Stream, for example, carries warm water from the Gulf of Mexico across the Atlantic to Western Europe. Without it, Europe would be significantly colder, possibly experiencing Siberian-like winters. Other currents like the Kuroshio, Agulhas, and Humboldt likewise regulate regional climates and affect everything from hurricane strength to rainfall patterns in equatorial Africa and South America. A shift in these currents could cause global droughts, crop failures, and mass migration. Number 77. Zombie worms feast on bones in the deep sea. Ostacs, or zombie worms, are a genus of marine worms that feed on the bones of dead whales and large fish. These pink, root-like worms bore into bone with acid and then rely on symbiotic bacteria to digest the fats and proteins inside. They have no eyes, mouths, or stomachs. Females dominate the colony, while dozens of tiny males live inside their bodies, never leaving, never growing, just producing sperm. Whale falls provide an entire ecosystem that lasts decades, with zombie worms playing the role of decomposers. Number 78. The ocean has underwater rivers and lakes. In addition to brine pools and submerged waterfalls, some regions of the seafloor host underwater rivers carved by saltwater brine. These rivers flow along channels with their own banks, tributaries, and even currents, visible with special submersibles. The Cenote Angelita in Mexico and Black Sea's Bosphorus Strait are examples of where you can swim through a literal underwater river due to density stratification. These formations carry nutrients and shape ecosystems in unique ways. Number 79. Comb jellies are older than dinosaurs, and possibly all animals. Ctenophores, or comb jellies, may represent one of the earliest forms of animal life. Some evidence suggests they diverged from other animals before even sponges. Despite their fragile appearance, they've survived for hundreds of millions of years, predating dinosaurs and even trilobites. They move by beating tiny hairs, cilia, along their bodies, creating a shimmering rainbow effect. Some species use colloblasts, sticky cells instead of stingers, to capture prey. Their simple elegance masks an ancient legacy. Number 80. Some deep fish have mirror-like skin that makes them invisible. Creatures like the hatchetfish and deep-sea squid possess skin that reflects light in all directions, like a mirror. This biological cloaking device renders them almost invisible in the faint glow of the mesopelagic zone, where predators often hunt by spotting silhouettes. These adaptations are so efficient that defense companies have studied them for developing stealth materials. The trick lies in how the guanine crystals in the skin scatter polarized light, something even advanced human materials struggle to replicate. Number 81. There's an ocean current so powerful it encircles the entire planet. The Antarctic Circumpolar Current, ACC, is the strongest and longest ocean current in the world. It flows unbroken from west to east around Antarctica and moves up to 150 times more water than all the world's rivers combined. This current helps isolate Antarctica, keeping it cold and affecting global climate and nutrient cycles. Without it, Earth's oceans and climates would look drastically different. It plays a key role in cycling carbon and balancing temperatures. Number 82. Some coral polyps glow to protect themselves. Certain corals glow in vibrant colors, neon green, orange, blue, not just for beauty, but to protect themselves from UV radiation and heat stress. These fluorescent proteins act like natural sunscreens, shielding the coral's internal algae from sunlight damage. During bleaching events, some corals increase this fluorescence dramatically in a last-ditch effort to lure new symbiotic algae. It's been described as a glow of hope, signaling that the reef is still fighting for survival even under stress. Number 83. Deep sea creatures use pressure to their advantage. At extreme depths, pressures reach over 1,100 atmospheres, equivalent to the weight of a full-grown elephant balanced on your thumb. Yet deep-sea creatures not only survive, they thrive.
How?
Their cell membranes and proteins are pressure-adapted, flexible, fluid, and stabilized by special molecules like piezolites. Instead of collapsing, their bodies use pressure to regulate chemical processes. If brought to the surface quickly, many simply dissolve or explode due to the dramatic change in pressure. Number 84. The ocean may have hidden earthquakes no one can feel. Most earthquakes go unnoticed, especially those deep below the sea. But some generate slow slip events, or silent quakes, that happen over weeks or months rather than seconds. These don't shake the ground, but they release enormous amounts of energy and can trigger tsunamis or lead to sudden, more destructive quakes. These events are detected by seafloor pressure sensors and GPS arrays. They're rewriting our understanding of tectonic movement and helping scientists better forecast earthquakes and aftershocks. Number 85. Deep-sea octopuses can guard their eggs for over 4 years. The Granulidone boreopacifica, a deep-sea octopus found off the coast of California, holds the record for the longest egg-brooding period of any animal, 53 months, for 0.5 years. During this time, the mother doesn't eat, drifting quietly and fanning her eggs with water. Once they hatch, she dies. The young emerge fully formed, ready for the abyss. This extreme dedication ensures survival in a world where food is scarce and danger is constant. Number 86. Some deep-sea organisms are radioactive. At hydrothermal vents, life thrives despite exposure to naturally occurring uranium and thorium in the rock. Some bacteria and archaea living there can tolerate or even thrive on radioactive energy, absorbing it and using it in their metabolic processes. In a few cases, microbes have been found that repair their DNA faster than radiation can damage it. These organisms have potential uses in bioremediation, such as cleaning up radioactive waste or surviving long-term space missions. Number 87. There are bioluminescent light shows visible from space. Massive blooms of bioluminescent plankton, particularly Noctiluca scintillans, can create glowing blue waves that illuminate coastlines. These blooms have been photographed from the International Space Station, covering hundreds of square miles of ocean. The phenomenon is called Milky Seas and has been reported by sailors for centuries. It's still poorly understood, but satellite technology is now being used to study when and where they form. They're mesmerizing and sometimes toxic. Number 88. The deep sea has its own type of snowstorm, with fecal flakes. We've talked about marine snow, but in dense zones of biodiversity, like under productive surface waters, the snow can become a blizzard of falling biological debris. Fecal pellets, mucus, bits of jellyfish, and dead plankton rain down in thick flurries. These snowfalls are crucial for the biological pump, transferring carbon from the surface to the ocean floor. Some particles sink slowly. Others form aggregates that drop rapidly, fueling entire benthic ecosystems and locking away atmospheric CO2. Number 89. The ocean's pH is changing faster than any time in 300 million years. Since the Industrial Revolution, the ocean has absorbed about 30% of human-produced CO2, leading to a measurable drop in pH. Ocean pH has fallen from about 8.2 to 8.1, which may sound small, but it represents a 26% increase in acidity. Such rapid acidification hasn't occurred since the Paleocene thermal maximum, about 56 million years ago, a period associated with mass extinctions. Today's rate is faster, raising concerns about the survival of corals, plankton, and shellfish. Number 90. There are entire ecosystems powered by nothing but hydrogen and sulfur. Most life on Earth depends on sunlight. But in the ocean's darkest depths, chemosynthetic bacteria live entirely off chemical energy, oxidizing hydrogen sulfide, ammonia, or methane released from the Earth's crust. These microbes form the base of food webs that support tube worms, crabs, and shrimp. Some bacteria even fix nitrogen and detoxify heavy metals. It's a life system utterly independent of the sun, and it has major implications for finding life on other planets and moons. Number 91. The ocean contains hidden underwater volcanoes, thousands of them. Beneath the ocean surface lie over 40,000 submarine volcanoes, many of which remain uncharted. These volcanoes form along mid-ocean ridges, subduction zones, and volcanic hotspots, and some are larger than Mount Everest, yet remain unseen. One such example is the Tiamu Massif in the Pacific Ocean, one of the largest volcanoes on Earth, discovered only recently. Most eruptions occur without warning and never reach the surface, yet they can cause localized tsunamis, birth hydrothermal vents, and reshape the seafloor on a planetary scale. Number 92. Coral polyps build reefs over thousands of years, one stone at a time. Though coral reefs appear rock-like, they're actually built by tiny living animals called coral polyps. Each polyp secretes calcium carbonate as it grows, slowly constructing the limestone skeleton of the reef. Over generations, polyps stack on top of one another, forming massive reef structures, some over 5,000 years old. The Great Barrier Reef, the largest structure ever built by living organisms, stretches over 1,400 miles, 2,300 kilometers, and is visible from space. Without polyps, there would be no reefs, no fish nurseries, and no tropical beaches. Number 93. The Sargasso Sea is the only sea without a shore. Located entirely within the North Atlantic Ocean, the Sargasso Sea is defined not by land boundaries, but by ocean currents. It's surrounded by the clockwise flow of the North Atlantic Gyre, making it the only sea bordered entirely by water. Named after the floating sargassum seaweed that thrives there, the Sargasso Sea serves as a vital nursery ground for sea turtles, eels, and fish larvae. It's a tranquil, nutrient-poor environment, but also an essential crossroads in the life cycle of many marine species, especially the European and American eels, which both spawn there. Number 94. Eels migrate thousands of miles to spawn once, then die. Speaking of eels, both European and American eels live most of their lives in freshwater rivers and lakes, but migrate thousands of miles back to the Sargasso Sea to spawn. Once they reach this mysterious destination, they reproduce and die shortly after. Despite being studied for centuries, no one has ever witnessed their spawning in the wild, and no human has seen a larval eel grow into an adult in the open ocean. Their migration is one of the most elusive and enigmatic phenomena in marine biology. Number 95. The deepest fish ever recorded was filmed at 8,336 meters. In 2022, scientists from the University of Western Australia and Tokyo University filmed a snailfish swimming at a depth of 8,336 meters, 27,349 feet, in the Aizu-Ogasawara Trench. This makes it the deepest fish ever recorded. Snailfish have soft, gelatinous bodies with minimal skeletal structure, perfectly suited for the crushing pressures of the Hadal Zone. These pressures would flatten submarines, yet these delicate creatures live and feed with apparent ease. Number 96. The deep ocean is full of ghostly, transparent creatures. Many deep-sea animals are nearly invisible, with transparent tissues that help them evade predators. Species like the glass octopus, salps, larvaceans, and comb jellies drift like phantoms in the deep, their organs visible through their gelatinous bodies. Being see-through reduces the chances of casting a shadow under bioluminescent predators and provides stealth in an environment without light. In many ways, deep-sea transparency is as effective as camouflage in a forest. Number 97. Some creatures have lenses made of crystals. While most animal lenses are made of soft proteins, the chambered nautilus and certain shrimp have evolved crystalline lenses made from calcite, a type of mineral. These lenses are incredibly precise, correcting for spherical aberration and creating exceptionally sharp vision, even in low light. Some mantis shrimp can detect polarized light and even ultraviolet, giving them possibly the most complex visual system in the animal kingdom. Their eyes have up to 16 photoreceptor types, compared to our 3, offering insight into a very different way of seeing the world. Number 98. Some seafloor creatures walk using feet made of water. Echinoderms like sea stars, sea urchins, and sea cucumbers move using a unique hydraulic system called a water vascular system. They pump seawater into tiny tube feet, creating pressure to extend or retract them. This allows them to crawl, climb, grip, and even pry open shells like mussels. Their movement is slow, but precise and surprisingly strong, especially for animals without a brain. A sea star's arm can continue moving even after it's been detached from the body. Number 99. Ocean microbes may be the key to understanding climate. The tiniest creatures in the ocean, marine microbes like Prochlorococcus, play an outsized role in Earth's climate. These bacteria are responsible for producing much of Earth's oxygen, fixing carbon dioxide, and regulating ocean chemistry. Some even form cloud-seeding compounds that affect atmospheric weather patterns. Despite being microscopic, their collective biomass outweighs all ocean fish combined. As ocean conditions change, tracking the health and behavior of these microbes could be critical to predicting climate shifts. Number 100. The ocean is our planet's final and most vital mystery. Despite centuries of exploration, over 80% of the ocean remains unmapped, unexplored, and unseen by human eyes. The deep sea is Earth's largest habitat, home to more diversity, more biomass, and more unknowns than any other region. We've explored the moon and sent robots to Mars, yet we know more about other planets than our own ocean. Its depths may hold answers to life's origin, new forms of intelligence, untapped medical breakthroughs, or entirely undiscovered ecosystems.